everyone.
Selamat siang. Okay, actually we are ready to start this webinar. And please, the time is yours.
Okay. First, can you see my screen now?
Yes, we have already seen your screen.
Okay. Okay, let's start for this webinar for the I have the vibration, so why I need the ultrasound technology. This SDT Ultrasound Solution that everyone.
Selamat siang. Okay, actually we are ready to start this webinar. And please, the time is yours.
Okay. First, can you see my screen now?
Yes, we have already seen your screen.
Okay. Okay, let's start for this webinar for the I have the vibration, so why I need the ultrasound technology. This SEC ultrasound solution that the question that I get from the most question that I get from the customer when I visit that they ask me about I already have the vibration, so why do I need the ultrasound? This is very interesting question for the that's what they are. So I have today I come up with 6 good reasons to give you for the why we need the ultrasound, because I already have we already have the vibration. I share this one. This is the 3 basic symptoms for detect the asset that we can detect from by the ultrasound. The first that we call the 3 assets we call fit FIT. You see the yellow screen here. F, this means friction, impacting, and turbulent. Friction does mean if example, if you have the under lubrication for the bearing has more friction, it like the ball bearing is slightly very slow. So and the next one is impacting. That means if everything has the impact, same like vibration, it will generate the impacting. All impacting generate the sound. The third is a T, turbulent. Turbulent just means the turbulent flow, because normally for the characteristic of flow, we have 2 characteristics of flow. The first is laminar. The second thing is a turbulent. So example, everything at that every leak for the gas leak or air leak is made the turbulent to generate the sound also. So the 3 assets that friction, impacting, and turbulent. This is the 3 assets that generate the sound. So we detect the sound, and it's different from the vibration that we detect about the energy of the impacting for the symptom. This is you can see in this video. This is a junior technician. They try to measure the sound from the chain wheel drive. This is we call the ODSR that we focus only for the ultrasound operation, drive, when safety, reliability. We don't want to have any accident. Incident happen when you detect or you measure data correction. But you see in this video, they just bring the sensor inside the safety fan and check. They don't want we don't want they bring hand inside the safety fan. So this is ODS, operation, driver, and safety for reliability. And the ultrasound we listen the defect in the real time. So every time when we detect, you see in this video, the junior technician guy is very build confident with the ultrasound. He just smile when he put the grease inside the barrel. Why? Because he know about the right quantity that he made, and he know that when he put the grease inside, it's the right quality, it's the right quality, it's the right grease, and he will know that the bearing is good condition or bad condition. That's why he is just smile. So the ultrasound technology will build the confidence of the technician when they operate on site to detect the data, correct the data, or operation to the maintenance the machine also. In this picture, we listen to this bell shift. This is the bell shift, and when you see the picture, what do you think about this? You can hear the sound. You cannot hear by your ear because that your ear is an audible sound. You can hear that. But when our ultrasound detector, you can detect listen the bell shift that the generator sound, and you can know that the bell is have the abnormal condition or abnormal operation or not. And the ultrasound is made the simplicity to build the confidence to the operator. That's it's very simplicity to build the confidence that we don't need about the expert operator to use the ultrasound, but we try to make everything is simplicity to build the confidence. This is our device to make that. So the next is competency, the timeline. So the path of competency for the statistician is far shorter than the journals of vibration analysis. If we compare between the ultrasound technician and the vibration guy, vibration technician also. If we compare the competency, it's really the big thing that to compare between the ultrasound and vibration. The right side, the right hand is vibration guy, the yellow guy, and the left side, the blue guy is ultrasound technician. How long we talk about how long is journey for the ultrasound and vibration. If we compare between the ultrasound technician and vibration technician guy, this one. For the ultrasound technician, the fully competent is around 7 months because ultrasound for the IO standard, we have the level 1 or level 2. But for the vibration, we have maybe you can use 2 years or 7 years for the experience. For example, like for study the certified level 1 until level 4. For example, that with it's not enough for just only 2 years, but it's more than 2 years until 7 years, depend on the competency of the operator also. So, but we talk about the vibration and the sound. The vibration and the sound are complementary condition monitoring technology. It's not a competitor or conflict the technology, but vibration and the sound, we can integrate or complementary the condition monitoring technology together. Like when you go the first time when you go to go to hospital, the first time you can see the doctor. No, the first time when you go to hospital, you can meet the assistant nurse. The first thing she will ask you everything like okay, how about your temperature, how about your fever, how about your condition now, where's your pain. This is a data corrector. So this is the ultrasound. technology that we do. We need to have the vibration to detect the filter every problem that happened, the first line different for the problem for the access. So when you go to the hospital, you meet the assistant nurse, they ask everything for you for your condition, then they will send to the doctor. And the doctor will decision for the hard decision to analyze it, what do you feel or what is your condition. The reliability maintenance or maintenance department, you should to have the one vibration analysis, but maybe 4 or 5 or 10 ultrasound technicians in your maintenance department, because this is the first digital line. You can filter everything for the problem of the machine. Then you can send every data corrector to the doctor, so the vibration analysis to analyze the problem. I try to explain you for the competency curve that for the ultrasound, what the difference between the ultrasound and the vibration. We know the config technology, but we can integrate together for the reliability maintenance. Again, if we talk about the vibration analysis, the first thing we think we imagine the bearing, the bad bearing or the good bearing. How about the defect in the bearing? But ultrasound is different. I remind you again, because ultrasound we have 3 assets. We can detect that: friction, impacting, and turbulence. So 3 assets we generate ultrasound. It's like this picture. This picture, if the top roof is a reliability roof, and they have the 8 pole or 8 pillar to hold the reliability maintenance here in the top. So for the ultrasound technology, we can do for the 8 pillar, we can separate the access for the 8 pillar for the ultrasound: mechanical, lead, lubrication, electrical, valve, stream, hydraulic, and tightness. This is all that with ultrasound technology can do over than the vibration can do it. For the first thing, we talk about the mechanical application pillar. Ultrasound, we can detect any defect of the mechanical system. We talk about the start-stop machine. We talk about it's not the non-rotating machine. We talk about the sliding machine, forward and reverse, clockwise or counterclockwise. So any mechanical system. It's not just only the rotating machine that the vibration can do. The second application is the leak application. The ultrasound technology can use the airborne sensor to find the webcam leak or pressure. I mean, when you go on the field and you use the ultrasound detector to measure the sound from your access, but the environment is very noisy. You don't care about it, because if you can hear by your ear, that means it's an audible sound. It's not the ultrasound. The sound is the frequency of the sound is above 20 kilohertz. So that means the human cannot hear it. We detect our device. We detect just only the ultrasound frequency. We don't detect the audible sound frequency. The third application is lubrication application. We can use the ultrasound to detect avoid over or under lubrication, the increased bearing ride condition. Example, if you have the one bearing, you don't know the bearing condition now, but when you put the sensor, It's same like the picture. You can measure under sound sensor and you can measure the sound. So you can know the condition, the bearing condition now because under lubrication or over lubrication. Why? Because that if the bearing is more friction, the friction when you measure the sound, if very sound you hear is very high, amplitude is very high, so this means your bearing is under grease or over grease. When you put the grease one shot inside, the decibel is going down, so that means now your condition of your bearing condition is under lubrication. When you put more until it's going up again, so that means it's enough when you put the sound inside, you put the grease inside the bearing. You can use the amplitude of the sound to decision that your bearing condition is over or under lubrication. The fourth application is electrical application. You can detect the medium high voltage system for the partial discharge also. You can find the arcing, tracking, or corona by use the ultrasound detection to detect that. Or we have the acoustic camera. Acoustic camera, this means the ultrasound camera can detect and you can analyze the type of the partial discharge by use PRPD curve to analyze the pattern of the partial discharge also. Or you can use this picture, the CT340 to correct the data, and you can analyze by the time waveform style when you record the data. Also, we have the valve application. You can access the valve tightness of and function. I think all manufacturers you have the valve maybe 1,000 or 2,000 valve in your manufacturer, but how do you know they work properly or not? It's leak or not? You can use the ultrasound device with the sensor to measure the sound when you close the valve, and because the process valve, if it leak, it take effect to the production also. At the same, we have the valve application. We have stream trap application. You can find the faulty stream trap or leaking component also. It's same valve because if the stream trap has failed, it will bring the water inside the process and have the defect in the process also. We use the same technology, but we can detect valve, stream, electrical, mechanical leak. And also, the next is the hydraulic system. We can detect, troubleshoot any hydraulic system for the passing or blockage because example, if you have the 4-cylinder, you can compare from the first until the 4th cylinder. And how about the sound? Example, if you measure the first cylinder 15 decibel, the second 16 decibel, the third is the 17 decibel, but the fourth cylinder is 2 decibel. So that means it have the internal leak inside or have something inside abnormal. So you can compare between the cylinder and you can measure the sound and you can analyze that this the hydraulic or cylinder has a problem on. The last application is a tightness application. It's very famous in the marine business, car manufacturer, or the airplane business also. Because every time when you maintain the ship, you have the welding inside. If you want to know your welding is cracked, is a good condition or not, you can put the ultrasound generator inside in the opposite side, and You can measure by the airborne sensor to scan if you can detect the sound from your welding here. So that means your welding is the bad condition because maybe have the internal crack inside. So there's only one technology for the sound. We can separate for the eight pillar: mechanical, leak, lubrication, electrical, valve, stream, hydraulic, and tiny system. Because that we want to focus on the we want to avoid zero waste, zero accident, and zero downtime. This is our ultrasound technology. The sound technology is represent a holistic approach to the condition monitoring and open our mind to more than just rotating assets. Because that ultrasound, we don't care about the direction or driving of the asset, but we just measure the sound that generate from the asset. That's why this is that I told you before, this is the versatility for the ultrasound technology. It's a different it's more over than the variation if we compare about it. And ultrasound allow us to detect that chain belt, coupling, conveyor, compressed air leaks, vacuum leaks, steam leak, electrical access, valve access. And why you inspection the coupling with the ultrasound? Because you cannot, if you have the one machine, you cannot stop the machine when you correct the data. It's different from the variation, because variation you need to put the sensor at the surface of the machine. But for the sound, we have this in this picture. We have the airborne sensor. We don't touch anything for the answer. We just measure the sound that generates from the clapping. So we reduce the need to unnecessary inspection or schedule and shutdown. We don't want to turn off the machine or shut down machine, but we can measure when the machine is operation. In this video, you see that this technician guy, he inspect the cupping by using the airborne sensor. He didn't touch anything, but the sensor will detect the sound that generates from the cupping. And if he found some problem, this is a QR code that you want to know more for the non-intrusive cupping inspection. You can scan QR code, and you can go through on our SDT website to learn more about the cupping inspection and cupping failure. This is the airborne application. And some application pose a challenge for the vibration analysis also. I think almost participants here that the vibration analysis guy. So if you see this video, what do you feel? The first is rotating machine, but it's very slow machine. So the speed is very, very slow, maybe 2 or 3 RPM. How about the vibration can detect or not? Then the sound is very high performance for when you detect a low speed machine or non-rotating machine or sliding or start stop reverse forward machine. I show you for the case study for electrical current through VFD fan motor bearing. I think almost it's not almost all manufacturers you have the VFD to drive motor. So this is if you have the problem for electrical current through a VFD fan motor bearing, we can fix this problem by we have the sharp grounding. We made a sharp grounding to the motor. Okay, but However, to require replacement every few years depend on the shaft rotating speed, brush tension, or the motor duty. How about if you forget to change or replacement the shaft grounding? If you put the grounding box in here, but you forget to replacement, what the effect? Let's I show you. This is it's for the paper mill industry. This case study from the ultrasound. This the left side is the bearing, the SKF, the deep groove bearing. Please focus on this the yellow line here. This is the time waveform when we correct the data, and this is the data that been correct from the July 2024. The decibel RMS decibel is around 33 decibel. This is the time waveform, and the y-axis is around 500 microvolt. That you hear the sound. The sound is just be correct, just only 3 seconds is enough for this machine. The RMS is around 33 decibel microvolt, and the sound is pretty good. It's just stable sound, and the time waveform is the good pattern. It's very stable. And the fifth month we correct that again, November, just only 4 months. We correct that again, but the RMS is going high, around 63, and you see the time waveform pattern is change different. Then you hear the sound. The sound is different now, and you see the y-axis. Before on July, it's a 500, but now it's a 15,000 microvolt now. So you see, this is before in the 500 in here. It's on July, but now on November, what different? The pattern different, have many peaks here, and the sound different. Again, we measure again for the next year, 2025, on February. You see the time waveform pattern is different. The sound is RMS is going high around 62 decibel, and you hear the sound. The sound is different, so it's not a stable same like on July when you make the first measurement, but you follow up the first, second, and the third sound. When you compare between the progress and deterioration with the y-axis scale information, you start from 500, but for January 2025, it's more than 10,000. It's a wide scale different. You see that the pattern is different and the sound is different. When we open the bearing, then the sound makes it easy to detect electrical arcing. You see the picture, the bearing fairly have like electrical arcing inside the outer rest. So the damage is similar to arc welding. The heat range from the temperature level discolor metal. Small crater form and metal has melted. So it's like a welding inside the bearing. Vibration cannot detect that, but ultrasound when we use, because we not detect just only the impact, but for about the friction, also generate the sound. That's why we can detect any kind of the mechanical problem. What about the sleep bearing also? The sleep bearing, this is we just install the ultrasound. You see the picture. We install the ultrasound sensor in here for the sleep bearing. Because if the vibration, if you want to measure sleep bearing, you should select the eddy current pole y-axis to see like orbit. But for the sound, because the sleep bearing have the oil and oil with two continuous signal. So every like a pressure change over or is generated the sound is like have because have the turbulence inside. It's like a vibration. So it generates the sound inside. We install the sensor and we can follow this picture we just installed on February. So if I for the next webinar, if I have chance to join the speaker, I will bring this data to show you for the how when we use the ultrasound technology to detect the sleep bearing. And this is the high performance the software of the ultrasound. We have the bearing toolbox. What is about the bearing toolbox? The bearing toolbox, this is our technology for the ultrasound. We have the upgrade for UAS3 ultrasound analysis suite 3, and we have the database of the bearing around more than 50,000 bearings for the manufacturer and the model bearing number. So every time when you correct the data for the sound, you download to the upload to the software, and you can just only select the bearing manufacturer or bearing number. Then you can use the bearing frequency to pinpoint about the frequency of the bearing, like a BPF4, BPFI, bond spin frequency, fundamental cake. You just select this video. You see, just select the manufacturer number, then you can pinpoint. So it's very simplicity for the ultrasound software. You don't need the expert. It's like a vibration analysis, but you just know the correct the bearing model or bearing manufacturer. Just select that and pinpoint to the data that you correct for the time waveform or spectrum. And this is the neutrality for the lubrication for the ultrasound also. Because this is expert on gun, we have the AI automatically to calculate the grease quantity. We install the ultrasound sensor. When the bearing have the more friction like under lubrication, the signal for ultrasound is going high, we send to the loop brain algorithm, and the AI will have the automatic analysis and send the signal to the auto lubricator. Auto lubricator, we put the grease inside the bearing. If ultrasound measure going high, we put the grease inside. If ultrasound is drop, we stop. If high again, we put the grease inside automatically. This is what we control by the AI algorithm model. It's just a little expert. Okay? So you don't need to have the manpower or technician to bring the grease gun put inside the bearing, but you just install just only one time, and then you just follow up an automatic auto lubrication inside by the ultrasound technology. There's this case study that I told before. This is low speed machine and lubrication. How about valve or steam trap? This is the ultrasound sensor we put in here for the steam trap application. When steam trap close, then you measure the time waveform here. When steam trap drain the water outside. The ultrasound is going high. It's like open and close, open and close. It's not just only always open or always close. You can see this video. You can know it's really simple. When you correct the how do you know the stream tap is good condition or bad condition? You just hear the sound and see the amplitude of the decibel. It's going high. It's just always close and open, close and open. It's okay. This is a good condition because you want to know the type of the stream trap, and you should know how it works. It's always if it close and open, close is open, it's a cycle. It's okay. It's a good condition. But sometimes it's there's a bad condition for the stream trap. It's just always open or it's always closed. You can measure by the ultrasound technology and you can hear the sound or you can see the decibels compare and you will know the condition of the stream trap is good. The same when you detect the valve for with the ultrasound. When you use the sensor to measure the sound in here, it's very low when you close the sound. But when you close the sound, close the valve, and you detect for the inside and out, the sound is different. So that means when you close the sound 100%, the sound from the outside it should be less than from in upstream. This is a video how to inspect the valve condition. When you measure the sound before close the valve, it's a good condition. The decibel should be same. But you measure the sound when after close the valve, decibel is going high. So you will know that because if you close the valve 100%, so that means no any flow in the upstream, in the downstream. But if you measure the sound from the inlet and outlet, it should be the same. But if you measure the sound from the inlet and outlet is different because because the valve, the outlet is going high, so you mean we have the something leak from the internal inside the valve. This is a stream trap and valve condition. So I told you before for all the application for the sound because that this is the PF curve or DIPF curve. When you design the machine after installation, when the machine starts to failure, it will generate the ultrasound frequency for. It seems like if you the vibration as it in Charlotte chart for the bearing failure, we have 4 states. The first state is a high frequency in the ultrasound frequency. That means when the bearing starts to failure, it will generate the ultrasound frequency first. So we can use the ultrasound strategy to measure it here. Then when the bearing moves to the second state or third state, it will generate the vibration, audible noise, heat, mechanical loss until it's breakdown. This is what the PF curve told you. The PF curve told you that how about the technology, how many technology that you have now in your maintenance department? Almost, I think you have the vibration technology and thermography camera thermal camera in here. Or some maintenance department, some manufacturer, you have the sound detector also. So that means if you have the ultrasound technology on the sound device is the first line defense because ultrasound is the oldest aspect because every time every mechanical problem is generated on the sound first. You can detect by the sound until it's moved to the low frequency, generate vibration, noise, and heat also. You can go back to your maintenance department and find that what the technology that you have now in the to the maintenance department to improve the reliability in your maintenance department. And the cost of the parts is the early balance that if we talk about if the machine breaks down, you have the downtime, work hour, 3 a.m. phone call. I think almost you have maybe like early morning have call or machine breakdown. Now production call you and your maintenance should be go now to fix the problem. The lost production, lost client, and poor quality, urgent work, urgent spare. You pay for the more expensive about the spare part, shipping costs, poor safety culture, energy efficiency. So all this is when the machine has a breakdown or unplanned downtime. This is cost for the maintenance. So if we want to avoid for the unplanned downtime, we should have the ultrasound technology with completely with the vibration technology together. Because if you can detect the early detect for the first line defense for the assets, you can reduce, you can avoid for everything for the unplanned downtime. And we talk about the return of invest also. It's just very fast. So I remind you again for the 6 good reasons for the sound technology competency with vibration. The simplicity, competency curve, versatility, airborne application, slow speed lubrication, stream trap and valve, cost and return of invest. If you can stop or zero downtime, or you can avoid for the unplanned downtime, you can find the return of invest also. This is my QR code and link in. You can scan and go inside if you want to know more for the SDT Ultrasound Solution. And this is Mr. Abiyan. This is his link in. You can access because of PT Tiara Weber-Sindo Pratama is our official representative in Indonesia. You can go visit them for the www.tiaraweb.com. And this is again for the QR code for the non-exclusive cupping inspection. If you want, you just scan the QR code and go to asset how to inspect the coupling condition by this ultrasound technology. Thank you very much.
All right. Thank you, Mr. Tanakorn, for your explanation. And we would like to start the Q&A session, and I'll choose some of the question. Untuk Bapak Ibu yang hadir di sini, apakah ada yang ingin bertanya melalui open mic? Oke, mungkin jika belum ada, akan saya bacakan beberapa pertanyaan yang sudah ditanyakan di kolom chat ya. Oke, Mr. Tanakorn, first question is from Pak Rahmat Farezi. The question is, as we all know, ultrasound allows for inspection without direct contact with the equipment. Aside from that, what advantage does this method offer compared to vibration analysis?
You mean the contact sensor, right?
Yeah.
Okay. because it's the first thing for the difference between the vibration sensor and the ultrasound sensor. Because the vibration sensor when you have the piezo system, then you detect the sound, detect the vibration, you detect the energy, you detect the vibration. How about if the vibration is not enough? How about if you detect the if the vibration is very low? Example, every sensor have the resonance when you put the sensor to the asset. If the vibration is very low, the sensor cannot detect, so you cannot detect anything for the vibration because what do you want to know? You just want to know the impacting. Impacting this mean in the time waveform on the spectrum have to show the peak separate from the elements. This is the first thing. But for the ultrasound, we detect the sound in the high frequency range. So every time when you measure in the world, you don't have anywhere have the sound. So when you measure from the machine, if the machine have the problem or just only have very low friction or impacting, it will generate the sound in high frequency. We don't detect the vibration, we don't detect for the energy, but we detect the sound that generate from the problem of the machine. So this is different. But for the sound, for the vibration, you need more impacting, more energy, and sensor, the vibration sensor, it can detect them.
Okay, thank you for your answer. We'll jump into the next question from Pak Rizwan, PLTD Supa. Is there any database or baseline for diesel engine?
Baseline for the 17.
Yeah, the ultrasound level.
In the sound level, we don't have the authority like a baseline for the diesel engine. Because why? Because it different from the vibration. Because vibration have the error or standard for 10 S S16 3. So the ISO standard for the vibration it fixed for the frequency 10 to 1000 hertz, and fix the type of the amplitude RMS, the velocity RMS. So you can control the factor. But for the sound, example, if you want to measure the sound, you should to fix the distance. If you close the source of sound, the decibel is going high. If you go away from the source of sound, the decibel is going down. So that's why the vibration in the isolation is control that it should be like a stable speed rotating. You cannot measure for the vary speed also, because vary speed the vibration is different. For the ultrasound, we don't have the standard like a severity the same like a vibration. That means any kind of the machine and diesel engine, fan, motor, we don't have the severity the same like ISO standard for the baseline. But we can measure, compare, listen with the other machine, or we can set the baseline like you set alarm same like a vibration. You can first measure, you can set the baseline system, and you can follow the trend. If trend is going high, so this means that your machine or your access has the more problem, more defect. That's it.
Okay, thank you for your answer. And the next question is from Pak Andi. PLN IPS KB1. Earlier, it was mentioned that ultrasound technology is used during ODR, but isn't ultrasound typically used in PDM or CBM? Also, how accurate is ultrasound technology in detecting leaks in valves and steam traps?
If we talk about the accuracy, what does mean for the accuracy? The first, if you want to have the authority for the example, if back to the so now is if you want to measure the example, you measure the steam trap, and the first is when you measure is a 20 decibel. It mean you don't know the condition, the first condition for the steam trap is good or not, right? Because it's just only for the time when you measure. But you can continue measure the second or third or fourth time, and you can follow the trend for the steam trap also. Uh, for the other brand that some ultrasound detector brand, they have the solidity for the just only steam trap. Like if you measure 20 or 30 decibel is good. More than 20 is fair, or more than 30 or 40 is the bad condition. This is they test on the laboratory. But for the IO standard, for instance, we don't have the authority for the steam trap. We don't have the authority for the any access for the ultrasound. So for the condition monitoring, also that we cannot set the the ISO standard for the ultrasound. Like we can use common for all kind of the access, but we can measure like a CBM that is through the condition monitoring. We can measure and set the baseline, and we can follow up.
Okay, thank you. And next question is from Pak Dimas Rinaldi, IPS BMPP Nusantara 1. How to distinguish noise from nearby equipment? As in birch-mounted power plant, all the equipment is situated in the same area. What is the best approach to interpret the data accurately?
Okay, the best approach for the data accuracy, because okay, I understand that when you measure for the if you want to measure like a electrical problem for the partial discharge example in the power plant, you have the in the environment you have the noisy, like it's not just only the audible sound but the ultrasound also. So our equipment for our, I think almost the ultrasound detector, you can vary the frequency. Example, example that's the acoustic camera also. When you want to measure something, or you use a vibration airborne, it's an ultrasound detector airborne sensor to scan. You can vary the range of the frequency. Example, if you found something is abnormal in here, and you know exactly for the frequency of the machine or the part that you want to focus to measure, you can set the range of the frequency. Example, if you know that your part have the problem is the frequency around 50k hertz, 50,000 hertz. So you can set just only maybe 45 until 50k hertz, kilohertz, and you can measure focus just only your access. Because normally for the airborne sensor or early or physically, we set the default just allow 25 kilohertz to 60 kilohertz. Is if you think this frequency range is wide, so you can set narrow for like okay 30 until 40 or 40 until 50 or 50 until 60, depend on your asset that you want to measure. But normally we should to set the wiring first, because we want to find some problem. Where is the problem now? Then you can set the rank is a small rank.
Okay, thank you, Mr. Tanakor. Next question is from ADF. When it comes to valve condition monitoring, how does ultrasound complement or outperform vibration analysis in detecting issues like leakage, cavitation, or improper seating?
If we talk about the vibration and the sound, because I'm the vibration analysis also before. If I go to measure the one machine like a more or like a pump or more, so I know if I have the vibration or maybe Cat 1 or Cat 2 or Cat 3 or 4, I have the certified for the vibration. The first thing that I know that it should be the type of machine should be the rotating machine, because vibration can measure that's only rotating machine. The second thing, it should be stable speed. Rotating speed should be stable. If not stable, it's very difficult to analyze. And the third, it should be continue rotating. It's not like a start-stop machine. So if compared with the sound, for the sound, we detect the sound that generate from the access or the machine or the part if you have the problem. So we don't care about the condition of the machine when they're rotating, start, stop, reverse, or forward, or sliding, or up and down. Also, that's the first is different. The second thing is same like if have the cavitation. When you use vibration to detect the cavitation in pump, you detect the impacting from the energy inside the pump. But for the sound, we detect the sound that generate from the cavitation inside the pump. What different? Maybe if the cavitation is very low energy, the vibration cannot detect. But the low energy in the cavitation generate the sound. So the low energy of the cavitation generate the sound. We can detect by use the ultrasound detector also. So what different? It's same like a low speed machine. When you use the vibration, low speed machine, you know that it's, I think almost it's very very low impact thing. So the vibration sometimes can detect, sometimes it's not detect. But for the ultrasound, for the low speed machine, all those speed machine have the friction and impacting that generate the ultrasound. That's why we don't care about the impacting of friction, but we detect the sound that generates from the equipment. It's a different. We detect that's only the sound.
Okay, that would be our last question for today due to limitation of time. Thank you for your presentation, Mr. Tanakor, and thank you for the knowledge you have shared. We hope it become useful insight for us all. Also, thank you for your answer in the Q&A session. And we are at the end of this webinar.
Yeah.
Okay.
You're welcome. If you have any question, you can send email direct to Mr. Abian, or you can inbox to my LinkedIn also. I can answer your question for all. Sorry for today that it's a lot of the question I saw that, but I cannot answer for all. So if you need more information for the strategy, or you can go to our website sdtultrasound.com, or you can go to LinkedIn for the SDT and inbox to ask me or Mr. Abiyan in the Tiara website. We I hope that I can answer to you for all questions that you want to know. And I appreciate that if you interest for the strategy, you can send email, ask the PTTR to go to demonstration, everything. And I have planned to go to Indonesia maybe in June or July. So if I have chance to visit your refrigerator, that is a good for show you for the performance for the strategy. So thank you very much. Terima kasih.
Okay, thank you, Mr. Tanakon, for your time. Karena keterbatasan waktu, izinkan saya untuk mengakhiri Q&A session. Untuk pertanyaan yang belum bisa terjawab, akan kami jawab di lain waktu.